Now let's talk about some interesting patterns which are related to the square numbers. If any two consecutive triangular numbers are added together, we'll get a perfect square. Now first thing to understand is what are triangular numbers? Now triangular numbers are the numbers whose dot patterns can be arranged as triangles. So if we have a number 1, this is how you arrange it. If we have a number 3, the 3 dots can be arranged to form a triangle like this. So the next number in the series is 6, which can be arranged in this format to make a triangle. So these are all called triangular numbers. So the triangular numbers are 1, 3, 6, 10, 15, etc. So now if you add the consecutive triangular numbers, say for example we add 1 and 3, we get 4, which is a perfect square. So if we add 6 and 10, we get 16, which is again a perfect square. If we add 10 and 15, we get 25, which is again a perfect square. But we are not getting, if we add 3 with 15, we are not getting a perfect square. So we are not saying adding any two triangular number will give you a perfect square. We are only saying that the two consecutive triangular numbers added together will give us a perfect square. Now let's look at some more interesting patterns. Numbers between two consecutive squares. Let's first see. First, consecutive squares means if you're taking a 2 square and 3 square, or 5 square and 6 square. So we are saying n square and n plus 1 square. The number of numbers present between them, between n square and n plus 1 square, will be 2n. So let's just take any value of n and see if it is true or not. So we take n as 1 in the first case. We have 1 square and 2 square, which is 1 and 4. So the numbers present between them are 2 and 3. So that is two numbers, which is 2n, where n was 1. Similarly, if we take numbers between 2 square and 3 square, in this case n is 2, and the numbers that we have to find is the number present between 4 and 9, which are 5, 6, 7 and 8. So if we see, these numbers are 2n, which is 4 numbers, n in this case being 2. So how do we reach this conclusion? We can simply do this. If we use an identity here, we are saying we want to find out the numbers present between n plus 1 square and n square. So we'll just subtract n plus 1 whole square minus n square. And what do we get by subtracting is 2n plus 1. So we simply use the identity a square minus b square, which becomes a minus b into a plus b, and that becomes 2n plus 1. So now these are the number which includes one of these numbers itself. So that means the number present between these two numbers would be 1 less than that, which would be 2n plus 1 minus 1, giving us 2n numbers present between the two consecutive squares. Another interesting pattern of square numbers is any perfect odd square number can be represented as a sum of two consecutive natural numbers, which are given by n square minus 1 by 2 and n square plus 1 by 2. So we are only talking about perfect odd square numbers. So we're not talking about numbers of the type 4, 16, but we're talking about numbers of the type 9, 25, and so on. So if we see take the number 9, this can be represented as sum of 4 and 5. And 4, if we see, 4 is n square being 9 in this case. 9 minus 1 by 2, which gives us 4. And similarly n square plus 1, which is 9, plus 1 by 2 gives us 5. So we are saying perfect odd square number will always be represented, can always be represented by a sum of two consecutive natural numbers, and the numbers would be given by n square minus 1 by 2 and n square plus 1 by 2. So if we take another number for an example, 25, again we get 25 minus 1, which is 24 by 2, that is 12, and 25 plus 1 by 2, which is 26 by 2, and that is 13. Now another property of square numbers is that the product of two consecutive odd or even natural numbers is equal to 1 less than the square of the number between them. Let's take an example of this. We are saying product of two consecutive numbers, where we are taking two consecutive odd numbers, which is 7 and 9, or we could take two consecutive even numbers, which could be 8 and 10 or any such numbers. So this is equal to the square, 1 less than the square of number between them. This 8 lies between 7 and 9. So 8 square minus 1. Now how do we get that? We can simply write 7 can be represented as 8 minus 1 multiplied with 9, which is nothing but 8 plus 1. So now using the identity a minus 1 in a minus b into a plus b, which is a square minus 1 gives us 8 square minus 1. So we are saying similarly we can take an odd number example also, which we are taking 10 into 12 is equal to the number between them, which is 11, in this case 11 square minus 1. It is 1 less than the square of the number between them. Now let's see what are the Pythagorean triplet. So first of all we'll go through the Pythagoras theorem, and then we'll see what is this triplet. So we know that the Pythagoras theorem states that for a right angled triangle, we will just draw it also. So for a right angled triangle, we know that the hypotenuse square is equal to the base square plus the height square. So this is what the Pythagoras theorem states. Now the triplet, the set of three numbers which meet this criteria, the three numbers would be in this case base, height and hypotenuse. So these the set of three numbers which meet this criteria of base square plus height square is equal to hypotenuse square is called the Pythagorean triplet. So an example would be 3, 4 and 5 is a Pythagorean triplet. Why? Because 3 square plus 4 square is equal to 5 square. Now for any, we'll just find out a criteria by which we can find out the Pythagorean triplet if any one of these three numbers is given to us. So for any natural number m greater than 1, this is true when m is greater than 1. 2m, m square minus 1 and m square plus 1 will always form a Pythagorean triplet. So we can see in this, say for example, we take m as 2. So now we have m is equal to 2, 2m becomes 4, m square minus 1 becomes 3 and m square plus 1 becomes 5. So we are saying we get this Pythagorean triplet, which is 3, 4 and 5, by putting an m equal to 2. So this condition is true for any natural number m greater than 1. We'll have a Pythagorean triplet given by 2m, m square minus 1 and m square plus 1. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.